Welcome back. Thanks again for watching. We're going to be going over a blower door test today with Randy Williams. Randy, tell us a little bit about yourself.
Well, from northern Minnesota, not Pennsylvania.
Yeah.
So I do blower door testing, building diagnostics. I still do some construction. I also do some writing. But blower door testing is kind of my passion. I really like trying to figure out what's wrong with houses, and I'm looking forward to testing this one.
Yeah, and I'm putting the links to find Randy. He has a great blog, which I highly recommend. That's northernbuilt.pro.
Correct.
And then also a lot of great content on Instagram. So we're going to go ahead and get started. We're going to be going over a few things. We're going to start with the products that he's using to basically do all the diagnostic testing.
Fans, exhaust hoods, fans, stuff like that. This is the Edelman powered flow hood. This is a really nice unit for very accurate for testing exhausting equipment. So we have a bath fan here. We're wondering if it's moving air. We're not 100% sure. We don't know if it's hooked up outside. We just want to kind of make sure that it's operating correctly. So what we can do, it's a little bit noisy, but I've got my smoker. And to begin with, I'm just going to puff a little smoke. And as you can see, it's getting pulled out. So I know it's moving air, but is it moving enough air? I've got this powered flow hood, and how that works is we just put this over the fan. I have a small button here I push, and what it does is it's got a small motor here with a fan, and it matches the pressure of the exhaust hood, and it does mathematically. It tells me what the CFM rating is on this fan. So we're done, and it's showing us it's only moving 18.7 CFM. That's a pretty low flow rate. That's probably a 50 CFM, so it's not moving enough air. It's probably the ductwork that's pinched, or it's blocked off, or it doesn't exit the building. So something to look for, something that we can probably repair. This is my blower door set. We've got the fan and the hoses. I've got another ring in case this house is really tight. We might need that. I've got my manometer. This is the Energy Conservatory's DG1000, part of the Minneapolis blower door. Got a fan speed control, the bag, and back there's my the frame for the bag to set the fan in, so we can create a airtight seal in the house with the fan installed inside that bag.
So Randy, we're here in front of this big red door. So tell me what this is and how we're measuring.
Well, it's called a blower door. It's made by the Minneapolis blower door, the Energy Conservatory out of Minneapolis. What we're doing is we're actually testing the integrity of your air control layer. All the work that you've done into your air barrier, whether that be interior, exterior, combination of the two, could be in the middle of your wall assembly, your attic, your crawl spaces, or your basements. How all that's connected, we're actually going to test to see if you've made it continuous. Of course, in the new parts, that's kind of easier to accomplish. When you're in the older parts of the structure, really tough. They can be hard. But anyways, this fan will, what we're going to do is we're going to create a negative pressure inside the house. We're going to drop the pressure down to what's called a negative 50 pascals, and that equals 0.2 inches of water column. So if you think of a straw, think of a cup of liquid, and you suck up on that straw a little bit, you're drawing up about a 1/4 inch is all that you need to suck, and that's the pressure that we're producing in the house. Another way to equate it, which sounds actually a lot bigger, is a 20-mile-an-hour wind blowing on all sides of the house at the same time is another way. But it's not a lot of pressure. It's just a little bit. And the reason we're at 50 pascals is to kind of get us over the effects of wind or stack effect, or there's things that work against the house with the fan, and we want to be able to get a good reading, a good number, or a good test with the fan. So we're going to ramp this up, hit 50 pascals. We're going to let it do a series of tests. We're doing what's called a multi-point test. So we're starting at 50 pascals, and we're going to slowly drop the pascal number down to 15 pascals, taking pressure readings at each or flow readings at each mark. When it's all done, we're going to have a number. We're going to have a leakage number, both a CFM. We're going to know how many cubic feet of air is moving across the fan, and then we can manipulate that CFM number to give us an interchange rate or a leakage rate CFM per square foot of surface area
Mm-hmm.
of the structure. So we can look at different ways to of the
And
numbers.
why are we testing? What's the whole benefit of testing?
There's several.
Yeah.
Number one, you want to be able to control air infiltration and
Mm-hmm.
exfiltration. That's going to help your indoor air quality. It's going to help your comfort. It's going to help energy costs. Um, that's the big one. But there's also, when you get air coming in, depending on your climate, you could have some moisture coming in,
Mm-hmm.
or you could have a condensing surface somewhere in that assembly by the air moving. The air's got some moisture in it, and as it moves out or into the surface or to a surface, a cold or warm surface,
Mm-hmm.
we could end up with condensation, and that leads to mold or rot or problems
Yeah.
down the road.
So it's both durability, but also comfort. And I'm sure in
Exactly,
northern Minnesota, it's more on the comfort side, but also heavily on the durability
it is.
because you're going to have frost and
Mm-hmm.
a lot of other extreme conditions.
Yeah. I actually, when I'm in walls doing some renovations or work, I've seen a lot of installation that's frozen to, for instance, the sheeting, the wall sheeting,
Yeah.
where you go to remove that insulation and half of it stays. It's just stuck to that wall. And it's usually an air leakage issue where it's condensed on that backside and it's actually frozen that insulation. I've seen frost in attics. We get spots, or maybe a whole
Mm-hmm.
attic might be full of frost, and that becomes a problem in the spring when things warm up, and then it rains.
And that turns into bulk water because for the whole course of the winter, it's just
Exactly.
been building up. And even though a little bit at a time wasn't a lot, but when it collects, that's when you really have your
It
main
does.
issues.
Yeah.
Yeah.
Yeah. So
Awesome. Well, I'm really looking forward to kind of checking out your gear and then getting into the actual testing itself.
yeah, that's
So, hidden by the piles of stuff, which is my basement, there is a direct connection to the outside. How I missed this, I have no clue. That's crazy.
all right. So once the blower door test is complete, we're part of what we want to do is we want to see if there's any holes or any leaks, air leaks in this assembly. So we're going to do a little additional testing, and I've got some good equipment that'll help us find the air leaks. Number one is our thermal imaging cameras. We've got a good temperature differential between inside and outside. These are going to work great. But sometimes you can't use a camera. Sometimes that temperature difference just isn't there. I've also got some smoker equipment that will show us if there is an air leak. We can just put this in front of the opening and it's going to move that smoke around to show us. But sometimes this is really nice for the smaller, if you really want to find a small leak, but sometimes you want to see if there's a bigger leak. This is my newest tool. This is Retrotech's mini smoker, I think is what it's called. It's not mini though. This guy throws some smoke.
All right, guys, so we're hunched over. We're in my old coal room, so original to the house, 1890s. Randy's here. We're finding a huge air infiltration down here. So, Randy, if you want to just do that smoker.
Yeah, well, you can even see the cobwebs that are moving a little bit, but we get up in here and the smoke is moving pretty heavy. So we've got quite a few a connection to the outside that we're going to want to try to see if we can't figure out.
So there you have it. We basically ended up with about a 4.6 ACH 50. which I'm going to say is okay. There's some definite areas that I'm going to be working on to try to lower that number. Again, with all the connection points with the original 1890 constructed farmhouse. And thank you so much, Randy, for coming out. It's been a pleasure.
That's fun.
Thank you.
Thank you.
And it's always a pleasure to see you. And if you're not already subscribing to my channel, I do basically a lot more with Rockwool. This is obviously more of an air sealing video, but that's basically it. So till next time, rock on. So I'm just finishing up a great couple of days with Randy Williams. I just got to tell you, he is a great guy. We have such a great building community, people helping people, and that's all that really matters at the end of the day. My score today, it didn't come out as well as I wanted it to, but he really gave me some insight. And I got to tell you, especially with existing homes, it's very difficult to get the scores that we see in new construction. So with the blower door test, it really does help with finding different issues in your home. So even at a 4.6, and actually we ended up being able to kind of section off the new portion of the home, and I hit about a 2 ACH 50. And even with that, it was still kind of connected to the existing home, balloon framing, all these things that we used to build with that really weren't great for energy efficient. And I think everybody out there knows that. But getting it now to that next level is really what we need to do. So with people like Randy Williams and the other people like you watching, by learning, we're going to get there together. So thank you very much. Until next time, rock on.